here, continuing with this step number 5. So we need to consider what here? Consider what? The ratios. Consider the ratios with negative ones, because we need to find the entering variable. Consider the ratios with negative ones. The entering variable is the 1, but entering variable is the 1, having the maximum ratio. So entering variable is the 1 having maximum ratio. If there is no such ratio, if there is no such ratio with negative, then the problem does not have a feasible solution. So let me explain step number 5 in detail. What happens here? In step number 5, we need to find first the leading variable. How to find the leading variable? So we need to find the most negative among the xbi. Becomes the leading variable. Once we got the leading variable, we need to find the entering variable. So how to find the entering variable? So we compute the ratio between the zj minus cj row and the key row. So here we got the key row, and we need to compute the ratio between the zj minus cj row and the key row. So if then the entering variable is the one which is having the most the maximum ratio. Fine. So consider the ratio with the negative ones. So negative ratios we need to consider here. If there is no such ratio with the negative, then the problem does not have any feasible solution. So then we go for the step number 6. So step number 6. So what happens in step number 6? Convert the leading element. Convert the leading element to unity, and all other element of key column to 0 to get improvised solution. Fine. So step number 7. Repeat step 5. Repeat step 4 and 5 until either an optimum basic feasible solution is attained, or till an indication of no feasible solution. So let me explain step number 6 and 7. So once we got leading variable and once we got entry variable, we got the key element. Fine, once we got the key element, then we are supposed to go for the next simplex table. So put down the values of the next simplex table. So convert the leading element to unity, that is the key element, we need to make it to unity, and all other elements in that key column to 0 to get the improvised solution, and also go for the next values. Fine. So repeat the step 4 and 5 until either we got the optimum basic feasible solution or till an indication of no basic feasible solution. Fine. This is what dual simplex method. So I will repeat it for you once again. In step number 1, we have to convert minimization problem into maximization if it is. If the objective function is subjected to maximization, leave it as it is, continue, go for the next step. If the objective function is minimization, then convert it into maximization. Fine. So that is what the step 1 here. Whereas in step 2, convert the greater than or equal to type constraints into less than or equal to if at all the constraints are subjected to greater than or equal to. If I suppose to say in Kannada, ಯಾವಾಗಲೂ constraints greater than or equal to ಇದ್ರೆ ಅದನ್ನ less than or equal to ಗೆ convert ಮಾಡಬೇಕು. ಹೆಂಗೆ ಮಾಡಬೇಕು? By multiplying -1 on the both sides. Then go for step number 3 here. Express the problem in the standard form. So to express the problem in the standard form, we have to introduce the slack variables. So why we are supposed to introduce the slack variables? Because the constraints are subjected to less than or equal to. Fine. So once we introduce the slack variables, then the given LPP will be in a standard form. So once it is in the standard form, what we are supposed to do? We have to put the standard form of an LPP into the simplex table. So by solving the simplex table, we will find the basic feasible solution. So how to solve that simplex table? First of all, we have to calculate the value of Zj minus Cj, the complete row. So once we calculate the Zj minus Cj, there comes 3 cases. Out of 3, we will come across 1 case. So what are those 3 cases here? Case number 1, if all Zj minus Cj is greater than or equal to 0 and all x, bi greater than or equal to 0, then the current feasible solution is an optimum basic feasible solution. Second one, case 2, if all Zj minus Cj greater than or equal to 0 and at least one x, bi is less than or equal to 0, then the current solution is not an optimal solution. Then we go for the next step. But what happens in case 3? If any Zj minus Cj is less than or equal to 0, that is less than 0, fine, then method fails. We stop there and write it down. The given LPP does not possess any feasible solution. Fine. Then comes for step number 5. In this step is nothing but the difference between simplex method and dual simplex method. Whereas in simplex method, we are supposed to find the entering variable first and then we find leaving variable. But here we exactly do the reverse here. First we find the leaving variable by choosing the most negative among the xbi. So that becomes the leaving variable and it is called as key row. So once we got the key row, we need to find the key element. To find out the entering variable, we compute the ratio between Zj minus Cj row and key row. So we need to consider the ratios with negative ones. Fine. So entry variable is the one which is having the maximum ratio, which is negative. If there is no such a ratio which is negative, then the problem does not have any solution. Fine. Or any feasible solution. Then what is step number 6? Convert the leading element into unity and all other elements in the key column to 0 to get the optimal solution. Fine. Once we got the key element and the key element, that is once we got the leading variable and entering variable and the key element, again the procedure is same, as good as simplex table only. The only difference here in simplex and dual simplex is that step number 5. Fine. So remaining all steps are as good as simplex method only. Fine. This is what the dual simplex method for you. Thank you.